Welcome back to part 2 of 205A on service conductors for residential houses. We're going to look at a housing example. We're going to go through Rule 8200 step by step together to make sure that you understand how it is that we get from just having a drawing in order to get all the way up to what the calculated ampacity of the house could be. We are going to use that information again to go through and discover what is the minimum ampacity of my service conductors. Let's take a look at this single family house. This house is a 2-story house with a full basement and each floor is 130 square meters. We're also going to include a 4 kilowatt electric space heater, a 7 kilowatt air conditioning unit, a 16 kilowatt range, a 7.5 kilowatt hot tub, 2 EV chargers, a dryer, deep fryer, a microwave, and a dishwasher. We are going to go through Rule 8200 step by step to see how we are going to use all this information in order to build out what our service specifications are going to be. Anytime that we do a service calculation, we need to break down our information into 2 separate categories. The first category that we're going to break it down into is the basic living area load. And this takes into account all the general use circuits. Any circuit that is in your general use areas, such as your lights or receptacles, would all be included in this basic amount. Any appliance that's less than 1500 watts is considered to be a basic living load. In order to get our basic living load, we have to do a calculation on our square footage by using 8110, in which we use 100% of the living area on or above the ground floor, and then 75% of the basement. The other thing we need to consider is any larger demand loads. So these are any appliances accounted for as per 8200 or anything that's bigger than 1500 watts. These loads have specific demand factors that we have to pay attention to because we cannot always predict how they'll be turned on or when they'll be turned on or how much they're going to be using. 8200 is going to show us how to include all these different types of loads into our service calculation. First thing we're going to do is we're going to look at 8110, which is determining what our areas are. We are going to use 100% of any areas above the ground floor that are used for living purposes and 75% of the area below the ground floor. Now the ground floor is defined as the floor in which you gain entry. So wherever your front door is, that's what your ground floor is. Anything above the ground floor, if it is an attic space, for example, that you do not use for living purpose, we do not include it. However, if we do have a bedroom or a workroom or an art room or whatever the case is up in the attic, then yes, we would include that in our calculations. As far as the basement is concerned or the area below the ground floor, all that is going to be included at 75%. The reason that we include it at 75% is simply because there's areas in our house that are not considered to be livable areas, such as our furnace room and our stairwells. In order to account for these non-livable areas, we're only going to include 75% of our basement floor. If we happen to have a split level house, we need to still be able to define what is a ground floor, our upper floor, and below the ground floor. Remember that the ground floor is any floor in which we gain entry. So the level that you come in your front door will be a ground floor. Therefore, anything below that level, that is going to be considered our basement or below the ground floor. In this example, we actually have 2 spaces below the ground floor. Therefore, both those 2 spaces will be taken at 75%, where the ground floor and the upper floor will both be taken at 100%. So let's see how this is going to affect our house. We have a 2-story house with a full basement and each floor is 130 meters square. According to Rule 8110, we need to take 100% of the ground and upper floors and 75% of anything below the ground floor. This means that for my main floor, I'm going to take a full 130 meters square. For my upper floor, I'm going to also take a full 130 meters square. But for my basement, I'm going to multiply that 130 meters square by 75%, which gives me a value of 97.5 meters. I want to add all 3 of these spaces together to get 357.5 meters square. This is the information that I need in order to move forward and use Rule 8200. Rule 8200 tells me that I need to break up that full living area that I've calculated into separate chunks and segments. And 8200 states that for the first 90 meters square, I give it a basic load of 5,000 watts. So no matter how big my house is, my service cannot be less than 5,000 watts. simply because this is going to accommodate all the lights and all the plugs that are just found generally throughout the house. If my house exceeds 90 meters square, then I have to add 1,000 watts for every 90 meters square or portion thereof. This means for us, since we have 357.5 meters square, I'm going to first put a value of 5,000 watts for the first 90 meters. If I subtract that 90 meters off the initial value, I have 267.5 meters squares left. I will take off another 90 meters square from that and assign another 1,000 watts to it. Now my value is down to 177.5 meters square that I have not accounted for yet. So I'm going to take my next 90 meters off of that, and as I do that, I'm going to add another 1,000 watts to my basic load. My remainder at this point is 87.5 meters square. The code says that I should take 1,000 watts for every 90 meters square or portion thereof. So I still have this 87.5 meters square that I have not accounted for. I'm still going to have lights and plugs in those areas. Therefore, I still need to add another 1,000 watts onto this. This means that for my basic load, for my general use plugs and lights and switches, I'm going to have a total value of 8,000 watts. Now, being organized is a very important thing. So what I suggest that you do is that you start a list on the top right-hand side of your page that lists all of your pertinent loads. And we're going to start this with our basic load. So our basic load goes on a list at 8,000 watts. The next part of 8200 deals with electric space heating and air conditioning loads. We have to pay attention to how we do this. In this house, we have 4 kilowatts of electric space heating and we have 7 kilowatts of air conditioning load. 8200 states that we should deal with the electric space heating as per section 62. In fact, 62.118 sub rule 3 is exactly where we want to go to look at this. This rule states that for the first 10 kilowatts of electric heat, we're going to take that all at 100% demand factor, plus the balance of any connected load over that 10 kilowatts is at a 75% demand factor. Normally, in a residential house, we don't need to worry about this rule because we're always going to be less than 10,000 watts. However, as we move through and start looking at apartment buildings, I want you to remember this rule, 62.118 sub rule 3, because we will be coming back to this one. The other thing that 8200 tells us is when it comes to looking at electric space heating and air conditioning loads, we also have to look at rule 8106 sub rule 3. This rule states that where it is known that electric space heating and air conditioning loads are installed and will not be used simultaneously, whichever is the greatest load shall be used in calculating the demand. Now, there's only one way you can determine whether or not the space heating and air conditioning will be used simultaneously, and that's whether or not they are interlocked. The easiest way to interlock appliances when it comes to heating and air conditioning is to make sure they're on the same thermostat. So if you have a building where you have a heating unit and an air conditioning unit both being controlled by the same thermostat, then they're interlocked. And in that case, we'd only use the larger of the two values. Since we're going to size our service to handle the biggest load, we can safely ignore the smaller load since they won't both be working at the same time. In our example, we don't have any interlocking, or we haven't stated that we have any interlocking. Either way, there's no way to control whether or not I can run my space heating and my air conditioning loads at the same time. I could, for example, have a baseboard heater and an air conditioning unit inside my window, and I could physically turn them both on at the same time. Therefore, I have to account for both loads within my service. When it comes to our service here, we're going to take the 4,000 watts for our heating, add it to our 7,000 watts for our air conditioning. We get a total of 11,000 watts, and we're going to put that load up on our list. The third thing that 8200 tells us to take care of is the electric range. It's important to remember that this is only for an electric range. If the house has a gas range, we can safely ignore this. However, in this case, we do have a 16 kilowatt range. 8200 states that we are going to be using this on the usage demand and not the full rating. We start by giving it an automatic demand of 6,000 watts for the first 12 kilowatts of rated demand of the range. So our range is 16 kilowatts. The first 12 kilowatts we're going to put in a usage demand of 6,000 watts. So if you think about your range, when you're using it, you never use the entire thing all at the same time. If you have 4 burners on top and the oven, sometimes you use the oven and 1 or 2 burners, but chances are you're not going to use the entire thing. And even if you did have all 4 burners and the oven running at the same time, the heating elements are actually what's called a cycling load. So the heating elements themselves will be turning on and off, so we won't have that full demand of 16 kilowatts ever at the same time, and the appliances have been built to achieve this. After we take the first 6,000 watts for the first 12 kilowatts of rated load, anything that is over that 12 kilowatts has to be taken at 40%. In order to figure this out, we're going to subtract 12 kilowatts from our initial 16 kilowatts, and we have 4 kilowatts left. The 4 kilowatts is what we're going to take at 40%. Therefore, the demand factor value for that 4,000 watts is actually only 1,600 watts. So we're going to add the 1,600 to the initial 6,000 to get a total demand of 7,600 watts for this 16 kilowatt range, and we're going to put that up on our list. If our range was less than 12 kilowatts, we would just put 6,000 watts in and it doesn't matter. Even if we have a 3 kilowatt range, we still give it a value of 6,000 watts. That way, if someone wished to upgrade their appliance at a later date, there's still room in the service for them to be able to do that. The next part of 8200 is dealing with tankless water heaters. Now, a tankless water heater is anything that does not store water in order to heat. So if you have an electric water heater that has a tank, that's not what we're talking about. The code actually gives you samples of what they are referring to. So we're talking about pools, hot tubs, steam showers, and spas. The code says that everything goes in with a 100% demand factor. The reason for this is that anytime that that heater is on, for the steam shower or the hot tub or the spa or the pool, that heater is on 100%. And it's going to turn on anytime it needs to warm up the water. So we have no control about when that turns on and off. It's going to do it as needed. Therefore, the service always has to be ready for it. That's why we're going to add this in at 100%. So our hot tub is 7.5 kilowatts. We're going to put it in at 100% demand factor, add it to your list for 7,500 watts. The next thing 8200 tells us to deal with is the EV chargers. So there's a couple of rules that we have to pay attention to. First of all, 8200 says that we need to put in 100% of the rated demand of the EV charger. But what if you don't know what it is? Your customers just said, you know, I would like to have one. 86306 states that we must use at least a single receptacle CSA configuration 5-20R, which means it's a 20 amp receptacle, and it needs to be fed from a 125 volt branch circuit, which means we use a voltage divider 120. In order to figure out wattage when using voltage and amperage, we just multiply them together. So if we don't know what an EV charger is rated at, we simply use 2.4 kilowatts or 2400 watts. This would be considered to be a level 1 charger. 8106 subrule 11 also states that if we do have an EV EMS system, electric vehicle energy management system, installed, then we can safely just ignore the EV charger, because remember that the purpose of the EV EMS is to balance out your EV charger with the rest of the service. So if we do have one installed, we don't need to put that into our service calculations. With our service, we do have 2 chargers. They're both rated at 1.8 kilowatts. We're going to put them in at 100% demand rating. Therefore, we add 3,600 watts to our list. The last thing 8200 wants us to deal with is any other loads. So there's 2 things we need to pay attention to right now. First of all, this is going to be referring to any loads that have not already been talked about within this rule. So as you're going through the list, make sure you're striking off everything that we've already talked about so you don't double dip. Secondly, when it comes to using this rule, we have to pay attention to whether or not there has been an electric range provided for. If we did not account for an electric range earlier, if our house has a gas range, for example, we need to account for the electric range now. So therefore, we're going to use 100% of everything up to 6,000 watts. In our example, we don't need to worry about that. In our example, we have an electric range. Therefore, we're going to take only 25% of any other loads that are inside the house, with the exception of making sure that they are over 1.5 kilowatts. They have to exceed 1500 watts. If I have a 1500 watt microwave, that doesn't count because that's exactly on the line. But if that microwave was 1501 watts, then I would have to take 25% of that load. With our list, we have a 6.5 kilowatt dryer, a 1.3 kilowatt deep fryer, a 1.6 kilowatt microwave, and a 2.2 kilowatt dishwasher. Since our deep fryer is less than 1.5 kilowatts, we're not going to include that. That is not a load that we need to worry about. Everything else, we're going to take a 25%, add it all together, so we have an other load of 2,575 watts. At this point, we have accounted for all the loads inside the house that we need to worry about. We accounted for all the general use plugs and all the lighting and everything that's 1500 watts or less in our basic load. We've dealt with our heating and air conditioning. We've dealt with our range. We've dealt with our tankless water heaters, such as our hot tub. We've dealt with our electrical vehicle chargers, and we dealt with everything else that's inside the house that is a little bit bigger. We're going to add all these together to get a total wattage amount. This is a calculated load of 40,275 watts. Rule 8200 comes in two different parts. It comes in part A, which we just calculated, and it comes in part B. 8200 states that we have to use what is greater between subrule A and subrule B. Subrule A is everything that we just calculated, that 40,275 watts. Part B is the absolute minimum size of service that we are allowed to install based on square footage of the house. The square footage of the house is everything that is the main floor and up, so not including anything below the ground floor. Since our house is 130 meters square per floor, we have 260 meters above the basement. Therefore, the smallest possible service that we could put on this house is 24,000 watts. What we need to do is compare part B at 24,000 to part A, which is 40,275, and choose the larger of the two values. And this is the load that we're going to use in order to calculate our minimum calculated ampacity. We'll take that wattage value and divide it by our highest voltage divisor, in this case 240 volts, which gives us a value of 167.8 amps. This value is how much our conductors must safely be able to carry at any point in time. Now that we know what our minimum calculated ampacity is going to be, we can use this information in order to size our service conductors. So 8200 subrule 1 told us to determine the minimum ampacity based on calculated demand. 8200 subrule 3 states that the single dwelling is not to be considered continuous, so we don't have to worry about any continuous rules here. Therefore, we can take our calculated ampacity directly to table 2, and then we can figure out our conductor size. We are going to assume copper conductor in a rigid PVC conduit. So there's a few things we need to know in order to choose our conductor size. We need to know what our minimum ampacity is, which we just calculated out. We need to know what our conductor material is, which is going to be a copper conductor. We need to know what our insulation type is, which in our case is going to be an RW90 conductor. And we need to know what our termination temperature is. And in our case, we're going to assume a 75-degree termination temperature. So our minimum ampacity that we just calculated was 167.81 amps. We know it's copper, we know it's RW90, we know it's 75 degrees. We take this information now to table 2, and we look at the temperature rating of the wire and the equipment. 90-degree temperature rating on the wire, 75-degree temperature rating on the equipment, therefore we use the 75-degree column. Now pay attention to rule 4006. If you don't know what the termination temperature is, this rule tells you what to assume. And we can assume, according to rule 4006, it is going to be a 75-degree termination temperature if it is over 100 amps, in which case we are. We're going to locate the number in the correct temperature column on table 2 that equals or exceeds our minimum ampacity. So we're going to look for a value equal to or greater than 167.8 amps. and we're going to find out that is going to be a 2-odd conductor rated at 175 amps. This is our service conductor size. It is going to be a 2-odd conductor. Our next step is to choose our overcurrent device. Our overcurrent device is not there to protect anything except for the conductor. Therefore, we use the conductor ampacity and not the calculated ampacity to choose our breaker size. When you turn to table 13, you will look for 175 amps within that table, and you will choose the appropriate breaker. This tells you your greatest possible breaker size is going to be 175 amp breaker. All right, you have made it all the way through part 2. Make sure that you are reviewing the service calculations in the modules. There's a few examples in there. You should be going through those. I also have worksheets within Blackboard that you should be printing off and going through. Make sure that if you do have any questions about this or you're not getting the right values, contact me and I can help you out. Or work with another student and see if you can help each other solve the equations. When you're ready, continue on to 205A Part 3.